Let us discuss about Karl Pearson coefficient of correlation, that is denoted by small r. In case of individual series, formula of r or correlation coefficient is equal to covariance of xy over standard deviation x standard deviation y. As we know that covariance is square of standard deviation, so standard deviation of combined xy over standard deviation x standard deviation y. So covariance xy can be termed as a sigma xy over n over standard deviation x standard deviation y. So next formula is sigma small xy over n over standard deviation x standard deviation y. When we are elaborating it, so this n will go to denominator. So formula is sigma xy over n into standard deviation x, that is a under root sigma x square over n, and under root sigma y square over n. So common is under root n and under root n, so it will be 1 over n. So n and n are crossed, so formula is sigma small x y over under root sigma x square sigma y square. So this is a basic formula actually. Now if we want to calculate it from the actual values, formula will be sigma x, that is the original values, product sigma x sigma y minus sigma x sigma y over n over under root sigma x square minus, so mind it that this is a capital X, and capital X means actual values, not deriving, not a variation. So actual value we are taking over here, under root sigma y square minus sigma y over n whole square. So this n can be taken as a LCM, and formula will be n sigma x y minus sigma x sigma y over under root n sigma x square minus sigma x whole square under root n sigma y square minus sigma y whole square. If we are going to calculate from assumed mean or in the step deviation also, it will be n sigma dx dy minus sigma dx sigma dy over under root n sigma dx square minus sigma dx whole square under root n sigma dy square minus sigma dy whole square. So in case of bivariate group data, that is having frequency, so addition of f will be there everywhere, n that is sigma f actually, sigma f dx dy minus sigma f dx sigma y f dy over n sigma f dx square minus sigma dx f dx whole square under root n sigma f dy square minus sigma f dy whole square. So properties of Karl Pearson's coefficient correlation. First, R, that is a correlation lies between -1 and +1. -1 means that is perfect negative relation, +1 means perfect positive relation. R is independent of change of region and scale, that means if we are going to subtract or add something or divide something, there will be hardly any difference, correlation will be same. R is equal to bxy into byx under root, that means it will be regression of x on y and y on x. If multiplied and then taken under root, that will be r. If x and y are independent variable, then r is equal to 0. Thank you. Now let us discuss coefficient of correlation in case of individual series. Suppose we are having data of sales and expenses. Sale is 50, 50, 55, 60, 65, 65, 65, 60, 60, 50. And on the contrary, expenses are 11, 13, 14, 16, 16, 15, 15, 14, 13, 13. So both are individual series. First of all, we will calculate it from actual mean method. So in case of actual mean method, formula is sigma small x y over under root sigma small x square sigma y small y square. So small x is actually deviation from actual mean. So x minus mean. So in the column, first of all we have written x and total of x is there, and we have calculated actual mean from x series, that is a 580 is the total, divide by 10 observation, and we have got mean 58. Now deviation from actual mean, x minus mean, 50 minus 58 minus 8, 50 minus 58 minus 8, 55 minus 58 minus 3, and so on, and total of sigma small x is 0. So we have calculated small x square, minus 8 into minus 8, that is a 64, minus 8 square 64, minus 3 square 9, plus 2 square 4, plus 7 square 49, and so on, and we have calculated sigma small x square 360. Now on the contrary, y is there 11, 13, 14. We have calculated total of it, and that is a 140, and mean of that is a 140 over 10 observation, that is a 14. So deviation from actual mean, that is a small y minus y mean, that is 11 minus 14 minus 3, 13 minus 14, it is a minus 1, and so on, and sigma small y is equal to 0. Now we will calculate small y square, minus 3 square 9, minus 1 square 1, 0 square 0, and so on. It is the total is 22. So far we have calculated sigma x square, sigma y square, and now we will calculate small x into small y, that is minus 8 into minus 3, that is a 24, then it is 804, and total is 70. So in the formula we will put it, that is the sigma small x y, it is a 70 over under root sigma small x square, that is a 360, into sigma y square, that is a 22, and we have calculated 70 over 88.994, that is a 0.787. Now we will go for the assume mean method. So assume mean method, we want n sigma dx dy minus sigma dy over n sigma dx square minus sigma dx whole square under root n sigma dy square minus sigma dy whole square. So first of all we will take assume mean, and assume mean we have taken over here 55 in case of x, and 50 minus 55, it is a minus 5, 50 minus 55, it is a minus 5, 55 minus 55 0, and so on. We have calculated sigma dx as a 30, dx square minus 5 square 25, minus 5 square 25, 0, 25, 100, 100, and so on, and that is 450 is sigma dx square. Now we will calculate assume mean from y series, and we have taken 15 as a assume from y, and that is 11 minus 15, it is a minus 4, 13 minus 15, it is a minus 2, and so on. We have sum it, and that is a sigma dy is minus 10. Now dy square, minus 4 square 16, minus 2 square 4, minus 1 square 1, and so on, that is the total is sigma dy square is 32. Now dx dy, so dx dy, dx is minus 5 and dy is minus 4, minus 5 into minus 4, that is 20, and so on. We have calculated sigma dx dy, that is 40. Now putting it in the formula, we have got 10 bracketed 40 minus 30 into my bracketed minus 10 over under root 10 bracketed 40 450 minus 30 square under root 10 bracketed 32 minus bracketed minus 10 whole square, and that is again going to give the same answer 0.787. Now if we want to calculate from actual values, we will not take the deviations, we will take only aggregate of x 580, x aggregate of x is 580 and aggregate of y is 140, and x square is 34000 and y square is 1982. So putting it in the formula, n sigma x, that is a capital X capital Y, minus sigma x sigma y over under root n sigma x square minus sigma under root sigma x square under root n sigma y square minus sigma y whole square. So after putting, we are getting same answer, that is a 0.787. Thank you. Now moving toward discrete series. Suppose we are having data related to number of persons and their wages. Suppose age 25 is there and person is earning 10,000. Those number of person who are having age 25 and income 10,000, they are 4. And 20,000 earning 25 age persons are 6. Like that, there are 10,000 earning at the age of 45, there are 3 number of person. So these are the frequencies, and if we want to calculate over here correlation, so correlation can be calculated by preparing one table. That is, first of all we will write x over here and y over here, but these are 10,000, 20,000, 30,000, so these are in the multiplication of 10,000 and these are in the multiplication of 10. So we will make such arrangement that they are close to each other and calculation will be easy. So what we will do, we will assume from x 30,000 and we will subtract 30,000 from it. So what we will get 30,000, 10,000 minus 30,000, that is a 20,000 in the negative. But that is also a wrong thing, because again it is in the 10,000 figures. So we will divide it by the 10,000. We will calculate dx dash. So dx dash, that is 10,000 minus 30,000 over 10,000, that is minus 2. After minus 2, when we are subtracting 20,000 minus 30,000, that is minus 10,000 divided by 10,000, it will be minus 1. 30,000 minus 30,000 over 10,000, that is a 0. 40 minus 30, that is 10,000 divided by 10,000, it will be 1. 50,000 minus 30,000, that will be minus, that is a 20,000 over 10,000, that is 2. Now moving toward y, if we are having 25, 35, 45 and 55, we have taken 45 as a assumed mean. So 25 minus 45, that is a minus 20. So minus 20, again it is not equivalent to it. So minus 20 divided by 10, common factor we have taken 10, so it will be minus 2. Then 35 minus 45 minus 10 over 10, it is a minus 1, again it is a 0 and 1. So like that we have calculated dx dash and dy dash. Now we will write frequencies as it is here, that is 4, 6, 3 7 1 2 8 15 7 1 3 9 12 6 2 8 4 2 black. What we will do, we will make a box over here at the right side corner on the upper side, that will be sufficient for dx dy and f. So first of all, we will calculate over here minus 2 into minus 2, these dx dash and dy dash. So here it is minus 2 into minus 2, that is a 4 plus 4 into 4, it will be 16. Next, minus 2 into minus 1, it is a plus 2 into 6, it will be 12. Minus 2 into 0, 0 into 3, 0. Minus 2 into 1, that is a minus 2, minus 14. Then it is a minus 2 into 2, that is a minus 4, into 1, that is a minus 4. Minus 1 into minus 2, that is a plus 2, into 2, that is a 4. Minus 1 into minus 1, that is a 1, into 8, it is a 8. Then it is a 1, minus 1 into 0 into 15, 0. So minus 1 into 1, that is a minus 1 into 7, that is a minus 7. Then minus 1 into 2, minus 2 into 1, minus 2. Again here is a 0, 0 into 3 into minus 2. So wherever 0 is there, it will create 0 everywhere. Next, it is a 1 into minus 2 and minus 16. 1 into minus 1 into 4, minus 4. 1 into 2 into 0, it is a 0. 1, these are the 0, so we will put over here 0. Now what we will do, we will calculate only f over here. So f is here, f is a 4 2 3 8 6 3 9 8 17. Then it is a 27 32 20 and 4. Next is from here, this side, we will calculate f from here, that is 21, then 33, 32 and 14. From both sides it should be equal. 17, 27, 32, 24. It will be 100. From here it is also 100. So it is n or sigma f. So first of all we have got n, that is 100. Wherever n is there, we will put 100 over here. Next is, that is, we will calculate this f dx dash. 17 into minus 2, that is minus 34. 27 into minus 1, minus 27. 32 into 0, 0. 20 into 1, that is 20. 4 into 2, that is 8. And total of it is, that is sigma f dx dash, it will be minus 33. Now next we will calculate f dy dash, and how it will be calculated, that is a 21 into minus 2, minus 42 minus 33, 33 into minus 1, 32 into 0, 0, 1 into 14, 14, and we will add them and it will be minus 61. Next is dy square, dx square, minus 2 into minus 2, that is a plus 4, plus 4 into 17, that is a 68. Or you can do one thing, that you have already calculated f dx dash, you can multiply it with the dx. So minus 27 into minus 1, it is 27. Or you can square it and you can multiply it with the f. So next is 0. Next 20. 8 into 16. Now total is 131. Now in the same way we will calculate, that is minus 42 into minus 2, it is 84. Minus 33 into minus 1, 33. 0. 14 into 1, 14. Minus 61 into, sorry, it is a total now. Total is 131. Next is, we will add these boxes only. 16, 4, 20, minus 16, it is a 4. 12 plus 8 minus 4, that is 16. Then it is 0. Minus 14 minus 7 minus 21. And then it is a minus 4 minus 2, it is a minus 6. And total is minus 7. So we want to check it. F dx dash dy dash, it will be equal to this f dx dash f dx dash dy dash. How it is? We will add here 16 plus 12 minus 14, it will be 10. Then 4 plus 8 minus 7 minus 2, it will be 3. Then it is 0, then it is minus 20, and total will be minus 7. So put over here, these both should be same. Next is, we will put the values. Minus 7 we have taken. F dx dash, that is a minus 33. Here it is a minus 61. Here 131 minus 33 square, 131 minus 61 square. After solving, we will get 700 of minus, 21013 of minus, under root 13100 minus 1089, under root 13100 minus 3721, it is equal to minus 2713 over 120119379, and it is equal to, if we want to solve it, it is a minus 2713 over 109.59 into 96.85, and which will be equal to minus 0.256. So this is a R. So this is the way we will calculate in the discrete series, and the similar processes in the continuous series. How it is? When we are having data, suppose we are having data from 20 to 30, 30 to 40, 40 to 50, 50 to 60, we will make the mid values. And suppose we are having data 5000 to 15000, 15000 to 25000, we will take the mid value. So after taking mid value, again this process will be done and the answer will be same. So in the discrete series and continuous series, the process will be the same. Thank you.